Alright, we're doing the last video. Hey, we're talking about a little bit of detail with composition, and so here's the goal for this video. We are going to compose functions, but in this particular example, if you take a look at it, I'm giving you f of x, but I'm not giving you the equation, and that's what we're used to seeing. You're used to seeing f and g both are equations, and then you can plug into one, get the answer, plug into the other, or vice versa. Right? So in this case, f of x is a graph, and the graph represents a bunch of points. Right? So when we do this problem, we're going to have to go back to what we did with function notation and graphing. So let's take a look at the first example, and you'll see what I mean as we go. So in this particular example, I'm asking what is g of f of negative 2. So I'm saying let's find f of negative 2, get its answer, plug that into g, and that's going to finish the composition. So if you take a look at my graph, if you remember back to function notation, when I was talking about something like f of negative 2, okay, whatever came out of that, right, the thing that we don't know at the moment, that was actually the rest of the point. This represented the point negative 2 comma something, and so we go to the graph to figure out what that something is. So in this case, I'm going to go over to negative 2, and I can go up to the graph by going up 3 units. So there's a point negative 2, 3, and so what I'm telling you for the f function is f of negative 2 is actually equal to 3. Okay, so instead, in this particular example, f of negative 2 is 3, which means what I'm really asking for is g of 3. Okay, so I used the graph to figure out what came out when I plugged in a negative 2. Right, so now g of 3 just means let's do 3 squared minus 2 times 3 plus 1. Right, that looks like 9 minus 6. 9 minus 6 is 3. 3 plus 1 is equal to 4. So I'd say the final answer to g of f of negative 2, that's going to be a 4. Okay, same thing for the second one. I'm switching the order up. And I'm also switching the notation up so that you can get used to that. So in this example, I'm asking you to take 1, plug that into g, and then take that answer and plug it into f. So remember, we kind of move from right to the left and work our way out of the problem. So this problem says, let's go up here and let's plug in a 1. So that's 1 squared minus 2 times 1 plus 1. Okay, well, that's 1 minus 2. Well, that's negative 1. Negative 1 plus 1 is 0. So I'm asking you to take 0 that came out of g of 1 and plug that into f. So what I'm asking really for is f of 0, right? So took 1, plug it into g, a 0 came out. I'm going to plug that into f. Let's find out what f of 0 is. Well, if I go over to my graph, I'm saying it's 0 comma what? In this case, it looks like 0 comma 2. So the final answer to the second one is 2. Okay, so again, it's this idea that if I need to get anything for the f function, if they're inputting something into the f function, I just got to go over to the graph and find out what y value goes with that input. Right? We've done that before. We're just seeing it in the context of compositions now. Okay, so here's your last one. This one's a little bit more work, and that's because in this case, I'm not telling you specifically what I'd like you to plug in. So I'm saying take g of x, the function, the entire x squared minus 2x plus 1, because in this case I have nothing to plug in there. I have to use the whole expression. And I would like you to plug that into f. Here's the problem. We don't have an equation for f to plug into like we usually do. So if your first job is going to be to write the equation of this line, and once I know the equation of the line, I have something to plug into, and I can finish the problem. So if you remember back to Algebra 1, anytime we wanted to write the equation of the line, as long as we knew the slope, m, and the y-intercept, b, I could write the equation. Those are very easy to find in this case. My b value is this 0, 2, so I know right away that this is a b value of plus 2, okay? And I just have to find the slope. In this case, I can do that by counting boxes. It looks like I'm going down by 1, right by 2, which makes my slope negative 1 over 2. Okay, so that should not be entirely foreign to you. I know it might be a little while since you've seen it recently. Okay, if I want to write the equation of a line given its graph, I need to just count boxes to get a slope, and I need to look at the graph to figure out where it crosses the y-axis. So I'm going to use this, okay, and I'm actually going to erase y, and in its place we're going to put, this is actually f of x. Okay, so now when they ask the question, what is f of g of x? I know that I'm going to go find g of x, this x squared minus 2x plus 1, and I'm going to plug it in right here for x. Okay, so let's find out what it looks like. So f of g of x is going to be negative 1/2, okay, times this thing, g, x squared minus 2x plus 1, okay, plus 1/2. Or I'm sorry, plus 2. Okay, so I took the f function, I plugged in g where x was, and now we're going to simplify this. Okay, and it looks like if I just distribute, it's going to be negative 1/2 x squared plus x, because this is negative 1/2 times negative 2, which is the 1 that's right there, okay? And the negative 1/2 times 1 is negative 1/2 plus 2, okay? So the only thing I have left to do to finish this problem to get f of g of x is to simplify this negative 1/2 plus 2. So if you remember negative 1, again, this is a fraction thing, negative 1/2 plus 2, I can do as negative 1/2 plus 4 over 2, right? That's 2, but now I have my common denominator. That looks like it's going to be a positive 3 on top. So here's my final answer. Negative 1/2 x squared plus x plus 3 over 2. And this would be my final answer to f of g of x, which I'm going to fill right into this space right here. F of g of x equals, okay, this big expression right here.